Hello guys, welcome to the vBrownBag. My name is Concistre and I work for Dell EMC as a principal architect. And today I'm going to talk about Kubernetes networking. What I got in the agenda, let's start with the definition and then let's move into the Kubernetes networking model. Let's talk about the CNI plugin. Let's show or compare how the networking is done in Docker versus Kubernetes. And let's wrap up with some benefit of having NSXT in our data center. So the first thing, let's define what a pod is. So a pod is a group of one or more application containers. So from the networking point of view, a pod is an endpoint, and as an endpoint, it's going to get a unique IP address. A node is where the pod runs. It could be a physical machine or it could be a virtual machine. And a service is a group of pods that run in a cluster. So I group all the pods in order to have communication, internal or external. If we review the Kubernetes architecture that is in the picture, we can see that there is a component that actually controls all the network, and it's the CNI. So when we talk about the Kubernetes networking model, the Kubernetes networking model actually is not defined as there is not a requirements actually that we need to meet in order to have our network. So that requirement is we just need to have a flat network. All the pods should have an IP. The traffic flow should flow in any direction. So pod should be able to communicate with other pods, and a node should be able to communicate with pods and other nodes, and shouldn't be not involved in the operation. So it should not be nothing between pod or between nodes and pod. So let's describe a little bit more what is the container network interface. So the container network interface is a set of libraries written to configure network interfaces. So in other words, what the CNI is going to do is going to assign, or the plugin is going to assign network interface to my containers. So the CNI is actually an evolution of the RKT project. That is a project that is very traditional project in the Linux networking space that has evolved into what we know today as a CNI. So pretty much what we got here in the picture is the container runtime is going to support all the operation of adding, removing all the nodes into the environment. And the CNI plugin is going to add actually the interface into the container networks. It's going to bridge that containers into the network, and it's also going to assign the IP address. Let's actually talk about what's happening when we are connecting or communicating the pods. So the first scenario that we got is we got one node, and we're going to see into that node multiple pods. So we can actually have multiple options here how we are going to communicate that particular pod. So we can have a solution like L2 switching, or we can do something like L3 routing, or we can even use an overlay solution to encapsulate package to communicate multiple pods into multiple nodes. In that particular scenario, in the picture, I got just one single node, and in that node, I got two pods that they are going to be communicating by IP. So the communication inside of a node is by IP. So now let's explore scenarios where I got multiple nodes, and I want to communicate one pod in one node with a different pod in a different node. So the first scenario is we can do it through L2. So we can do switching to do that, to enable the communication. And in that scenario, what we're going to do is we're going to create a CUD bridge where all the pods are going to be connected. And then this is going to be connected to the physical adapter using the virtual Ethernet adapter. So in that case, all the pods are going to be communicating. So if I got pod 1 wants to communicate with pod 3 that is in a different node, it's going to run or it's going to execute an ARP request in order to know the IP, and then it's going to be the communication. Usually L2 connectivity is for a small deployment. We also got the chance to do L3 connectivity, that is what the cloud providers do. So when you go to Google or Amazon, they actually do L3 connectivity. And in here, what we do, of course, is routing. So pretty much we assign a default gateway to every single port, and the default gateway is gonna create a route table. So, and every single port is gonna get to the default gateway, it's gonna assign, it's gonna check the IP, and then it's gonna communicate. One example of this type of communication, or a project that actually ran the L3 communication across node, is Calico. The next type of communication is the overlay network. So in this one, in this scenario, I got multiple ports, and I'm gonna create a virtual network that is gonna run on top of the normal network that is created, and I'm gonna use something like GRE or VXLAN or any other type of encapsulation to send traffic between the nodes. For this one, the two project, or the most important project, is Flannel or WIF. So this project actually uses an overlay network technology. If we see from what's the difference actually between Dockers and Kubernetes from the networking point of view, we need to actually think about how the Dockers communication happens. So the networking for Dockers is, I got a single host with multiple nodes, with multiple containers. So in that way, every container is going to have their own IP address, but the communication is going to be through the port. So I'm going to have an IP address, and then the communication is going to be done through port forwarding. So because initially when Docker was released, there was meant to be, you got a physical host, and then you run all the containers on your physical host, and it wasn't meant to have multiple hosts. So in that case, in the Docker environment, when you got one host, actually all the containers that run in that particular host are not able to communicate with another host by default. So you actually need to create. So, and that's the difference with the Kubernetes. The Kubernetes is actually when we deploy Kubernetes, is having multiple nodes in the environment, and it can actually grow in a large scale. Finally, I'm gonna talk about the NSXT plugin. So the NSXT plugin is the plugin developed by VMware, and what it does is create logical network for each Kubernetes namespace. So the Kubernetes, the NSX plugin also connect logical network and allocate IP addresses and MAC address to the pods. It also supports NAT, and the NAT for ingress and egress from north to south traffic. So when we're talking about from the, if we got something like load balancing and a public IP, and then we want to translate that IP into the internal IP, it's also fully supported in NSXT. Also, you can implement firewall rules and network policies around the Kubernetes. At the end, there is actually more information around NSXT and all the product and all the project that I actually mentioned. The keynote or the takeaway of this presentation is, if you are going to deploy Kubernetes or you are going to run Kubernetes on premises, well, you definitely need to be aware, and there is requirements how you set up the network. But if you actually, on the other hand, are going to run Kubernetes on the cloud, in a public cloud, well, it's simple, because you don't have to worry. For example, Google or Amazon or all these public cloud providers, they will do the networking, and they will be able to communicate, or all the pods will have communication internally. Thank you guys for watching. See you next time.